welcome to Indiana basketball. And so hopefully you enjoyed. That's my audition video so I can play for the Harlem Globetrotters. But if they won't take me, maybe I'll be able to play for the Washington Generals. That's who always plays against the Harlem Globetrotters and loses about every single time. But hopefully you enjoyed that and are enjoying the nice weather in between rain showers. And, one time when we were traveling out to Colorado, we stopped at a restaurant in Nebraska, and the waiter goes, "Is it really true that everybody from Indiana, can they quote the movie Hoosiers?" And the guy brought our water, and then he left. And then when he came back to take order for food, I just started quoting some of the lines from the movie Hoosiers. You're playing Cedar Knob tomorrow night. No one knows him better than me. You got to squeeze him back in the paint. You got to make him chuck it from the cheap seats. Watch that purgatory they call a gym. No drive, 12 foot in. That'll do. And then also Chris's dad, he can say this one really good. It says, "Cletus, you tell him. Remember sectionals 33? 1 point down. 5, 4, 3, 2, 1. Let her fly. In and out." Well, I was fouled. And so hopefully maybe you can quote some lines from the movie Hoosiers. But, another quote is, "You're in the Army. You're in my Army. Every day, 3 to 5, or e-learning, 9 to 3. And my practices are not designed for your enjoyment. So we're teaching in a basketball jersey today and shorts. Shorts aren't even allowed to teach in at school. And so I guess I'll wear the jersey today. I wore overalls last week, so you just never know what's coming for the next e-learning day. And so for those of you that are involved in math counts and an academic Super Bowl, I had a link here for the academic Super Bowl competition outline. Here are some practice questions, and if you're serious about doing this, you want to click on these, and then the answers are right here, but you want to see what the questions are going to be like. You're going to have 40 minutes, and it's going to be on a Google form. And so you'll get a question. It'll say, what's the probability of A is 1/2, probability of B is 1/3, and A and B are mutually exclusive. What is the probability of A or B? In probability, when you see the word or, you add the fractions. When you see the word and, you multiply the fractions. And then you add them, and you get 5, 6, and the answer is over here. But it's this next one that we haven't gone over at all. And this has to do with exponential functions. And so with exponential functions, you have this. You might have after 20 years. Well, years is a time. And then it'll say K is 0.26. So you plug that in. And then we'll say after 20 years, 25,000 rabbits populate the area. Well, that's either going to be A, that's the initial, what you start with, or Y is the final, what you end with. And so if it says, how many rabbits did you start with originally? Well, that means the 25,000 is going to be Y. And so you're going to take E, which is a button on your calculator. It is above the natural log button. And if you do E, and you hit that, the second button, you actually get something that looks like E caret. And then you would type in 0.26 times 20, and that would give you a number, and that's what you'll divide 25,000 by. And then see if you can get the answer of 138. So I would work on these before you just go, I'm going to take the contest. And so, because we want a good score. And I don't think Discovery's taking it. And so we got a chance to get them. And Honey Creek, I don't think they're taking it either. And so a lot of schools that are our competition might not be doing it. And so we want you to take this contest. Okay? And so, but do go through these practice ones first. And so you're kind of familiar with them. There's another one. That's a negative exponent. And so that's when we're doing exponential decay, because the graph would go down and then decay. A positive would go then grow, like coronavirus stuff is exponential. Okay? And so you look through these, there's some function table stuff. 6th graders, you guys could do this. Yes, we can do function tables. And we're learning about graphing lines and what functions are, and then they have it mixed up. But there's about 20 questions here. I think the real competition might be 30. I think so. And you want to make sure you get it done in the 40 minutes. And so there is an interdisciplinary round too, and you can take that, but then you'll have some English and science and social studies questions that you might not be an expert on from the 1920s. But if you are, give it a shot. And less people will take the interdisciplinary, I guarantee it. So you want to make sure you do it because that gives you a good chance of doing well. This all has to be done by 10 p.m. Thursday night, 40 minutes for each test. So if you do the math one, it's 40 minutes. And so when you click on this, it's going to have you type in your email address, then go down our schools in the second list. Read the whole line. We are not Northridge Middle School of Crawfordsville. You know, that's where Lincoln and Kirsten live. Crawford. No, they don't. They live in LaGrange. But you pick the one that says Middlebury. Otherwise, we're giving good scores to another team. We don't want that. We want to keep our scores. Okay? And then you fill through. You have to commit to your honesty. Wait, get that off. And then the time you're starting. Is it AM? Is it PM? And then you have to keep track of the 40 minutes because on the Google form, if you take too long, they might just disqualify you. So make sure you're done. Set a little timer, 40 minutes, and get that done. Okay? And I don't really know what the questions look like because I don't log in. And so you need to take it without any notes, but use a calculator. And it said, even though on the practice round said you had to use a certain type, you guys, Millers, you know, you can use your Casios or Sanyos or smart whatever calculators you guys all use. So any of them are allowed this time. So don't worry about that. Okay? So take attendance and we'll get right back to the notes. So make sure you take the attendance now. Don't wait till Sunday night and then go, I forgot to take attendance. Get that attendance in. Okay? And so we'll be ready to go from there. In store for geometry today. And so today we're going to talk about minimal paths. And it's quite amazing that normally this would be the last section of the chapter. And then we'd have a review game. And then we'd take a test. But this is actually our last section on transformations. And then on Friday, we're going to talk about equations of a circle. And so we're just going to shift gears. So no review game, no test, just last of the new learning, and there it is. So make sure you are working on your warm-ups. Some of you don't have them done for this week, but some of you still have old ones to do. Carson, Charlie, Aiden, Kirsten, you know you have to do them and finish them, and so I can fix your grades. So get those in. And we already have couple pre-algebra people and an algebra person sending me their logic problems. Don't have any yet from geometry. Don't wait to the last minute. Get those logic problems turned in because then I can get them in the power school sooner. So don't wait around. Make sure you get them done. And if you like these videos on YouTube, the algebra students and the pre-algebra students always have more likes on YouTube for the videos than the geometry students. But I don't even know about all this stuff. We're just learning as we go. So make sure you print it off the notes. The homework's on there too. It's a worksheet. And so we're going to talk about minimal paths. And so we're going to break this down a little bit. And the first problem on the notes, it says, shown as a grid, where each grid's a tenth of a mile. You want to build a road from A to B, but when you cross the river, it has to be perpendicular to the edge. And so normally, if we were going to build the shortest path from A to B, we would just go from A to B. The shortest distance between 2 points is a straight line. But then the problem is, I'm going to build a bridge, and the bridge has to be perpendicular to the edge of the river. So should I just go like this? Would this make sense? To go to there and then cut across and then just connect that? Would that be the shortest path? Where should this bridge go? Should the bridge go, I need to move the arrow. Should the bridge go here? Does it matter? Does that change the length? Because wherever this bridge goes, you see, normally that would be the shortest distance. but I need to put this bridge in. Should it go there? Somewhere here? Should it always go at the average? The distance? Should it slide over here? Because if it slid over here, if this is where the bridge goes, then your homework is straight to the bridge, down the bridge, and there. And a straight line here. That's not straight. And don't you dare freehand it like that. And so where should this go? Well, here's what you do. However wide the bridge is, that, or the river is, that is how far. It doesn't matter if you move this point down or if you move this point up, but don't move both of them. Just move one. If I move this point down, we don't want that line anymore. I move that A or B, not both, just one, to there, the same width as the river, and then I connect. And now, if I connect these, which is going to be kind of crazy because it all shifts, but I'll show you why this works. Okay, move this guy back. I connect that to there. Now, why would that make sense? Well, because this is the shortest distance between 2 points, the red line. If I keep this from B to the river, got some lint or something stuck in the mouse. If I keep this, this is my answer. But what's going to happen is I'm just going to move these other two pieces. And this is the proof without actually proving it. If I take this piece and move it right to here, and if I take this piece and move it right to here, see how those are the same lengths? And this is where the bridge should be. The bridge should be right there. So your road would go there, there, and there. Now you might say, Mr. Nysten, it was the exact middle. It was the average of them. And that's because both of these are the same distance. This is 3 away, and this is 3 away. And so that would be the shortest minimal path. Now, the question says, what's the length of this path? Well, if you want the length of the path, just move it down here where we had our triangle. That's 6 by 8. So if we know our Pythagorean triples, Morgan, it's a 6/8 what? 3 squared plus 4 squared is 5 squared. So 6 squared plus 8 squared is, yes, Morgan, good job. It's 10. This is a 10. This is a 6/8, 10. But if each length is 0.1, this is 10 times 0.1. So what is 10 times 0.1? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.10. 0.10? No, 1.0. And so what is the length of the shortest road from A to B? It's a 1. 0.6 squared, because this would be 0.6 squared. This would be 0.8 squared, and you could just do it with decimals. You could say 0.6 squared, which is 0.36, plus 0.8 squared, which is 0.64, and 0.36 plus 0.64 adds up to 1, and that equals what squared? Well, the square root of 1 is 1. And so we could put miles, but we have that. And so that's just an example of minimal distance. This question right here says, is this bridge built at the correct spot to minimize the distance? If the bridge, so here's your river. And what we said to do is you move this bridge right here. You move either point P in perpendicular to the edge of the river, the exact same length. And so if you don't know it's the exact same length, you take that and you move it. You can either move this side in or you can move this side in. So if I move this side in and then I connect this point with that. And is that bridge built where it's minimally distant? No. The road should have been from here to here. Then this bridge, whoa. I guess it's not going to let me take it. But this blue should be right here, perpendicular. And so this piece right here should be right here. And then you connect with a straight edge to there. So the bridge is in the wrong spot. The bridge should actually be down further. It would be less distance, okay? And so just do your best when you're drawing it. You know, you could do your compass and mark off what's the length of the river, width of the river, and then move that over. Or use your mirror to try to get it perpendicular. And then notice we always have this parallelogram. This piece is really this piece. And this is really this. And so when we slide those and change them, that is how we get the minimal distance. Okay? So we're going to go on to the next one that involves the coordinate graph. Ones here, it says, find the shortest distance between a point and a line. And so we're going to plot the point 0, 5, which is going to be right here. And then we're going to graph the line y equals 2x, which starts at b is 0. Remember, slope 2, rise 2, run 1, rise 2, run 1, rise 2, 1, run 1. And so we graph this. This is going to be off a little bit. I hate it when it shifts, but that's just how it is in these days. And we want to find the shortest distance to the line. Well, key thing here, the shortest distance to the line will always be blank to the line. The new line will always be blank to the old line. What is that, Kaya? Yes, perpendicular. And so this has a slope of 2. This is going to have a perpendicular slope. Well, how do we know when slopes are perpendicular? What would that be, Jack? Yeah, opposite reciprocals. So if this line has a slope of 2, this line has a slope of -1/2. And so that's how you know if you have the correct line. Perpendicular slopes, opposite reciprocals. So Vadim, all we got to do is find the length of this line. Well, if this is 1 and this is 2, Vadim, 1 squared plus 2 squared equals what squared? What's the answer? Yes! Good job. And that'd be square root 5 is D. So the length is the square root of 5. Let's do the next one. When in doubt, draw it out. So move me down to this corner. Get the sound off my face. And here we go. It says, find the shortest distance from the point 4, 4. Well, that's right here. To line L, not line 1. That should be a cursive L. With equation -1/2 x plus 3. Well, if we start at 3 and we go down 1 over 1, down 1 over 1, and down 1 over 2. What am I doing? Down 1 over 2, down 1 over 2. And so we'll graph this. This one's going to be a little trickier. Or it could be a lot trickier. I have a line that if this has a slope of -1/2, my line that goes through point 4, 4 is going to have a slope of 2. So it's here. Well, this line, the tricky part is, it's not tricky to draw this. The tricky part is, where does it hit the other line? But that is why we were required to take algebra before we took geometry. At least when we were taking algebra, we were in class. We were not sitting home in our domiciles. I learned that word from the movie Hoosiers. Welcome to my domicile. Identify! And so, where do those two lines cross? Well, let me tell you, it ain't anything nice. Does that look like a nice spot to you? No, it doesn't. So I have an equation. That's this, -1/2 x plus 3. I also have another equation that is y equals, remember, point slope form, y minus y sub 1. Oh man, wake up the echoes, dun 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 dun. Yeah, clear out the cobwebs. And it's y times quantity y minus 1 equals m times quantity x, x minus x sub 1. And we have a point, 4, 4. So that's going here. And we have a slope of 2. So we have y minus 4 equals 2 times the quantity of x minus 4. And so I get y minus 4. Of course, those y's look like 4's. Y minus 4 equals 2x minus 8. And if I add 4, this just becomes y equals 2x minus 4. Now, if I set this equation by substitution, 2x minus 4 equals to negative 1/2 x plus 3, what would I get? Well, I'd get, well, maybe I should write it down. Negative 1/2 x plus 3 equals 2x minus 4. And so if I add the half x, I'd get 2.5 x over here. We'll just call it 2.5 x, 5 halves x, whatever floats your boat. That's a 2.5 x. This equals a 7. And so x is 14/5 x. And then if that's 14/5, what's y? Well, you could plug it in either place. Maybe we should just make this 2.8. That'd be easier. 2 and 4/5. If x is 2.8, I could just take that and plug that in right here for x. And so 2.8 times 2 is 5.6, and 5.6 minus 4 is 1.6. So this point right here is 2.8 comma 1.6. And I'm sure Carson had an easier way of finding that point. But he's not here. Mr. Nyson, I wish you could tell me. But otherwise, you're stuck with these long methods that I show you. Okay? So 2.8 comma 1.6. Well, then how do we find the distance between that and 4 comma 4? Well, we could use the distance formula. But just it's the change in y's. 4 minus 2.8 is 1.2. 4 minus 1.6, you know, if you made a little right triangle out of this and did the Pythagorean theorem, you would get, what, 2.4? And when one leg is double the other, it's the short leg times the square root of, Grant? Yeah, square root of 5. So your answer is 1.2 square root 5. Or we can just do this out and pretend we never knew that. We just play dumb. 1.2 squared is 1.44. 2.5 squared is 5.76. 1.44 plus 5.76 equals 7.2. And the square root of 7.2 is 2.68. And is that the same thing as 1.2 times the square root of 5? You betcha. Right there's a humdinger. I learned that word from movie Hoosiers too. We got myself a humdinger. I did. I was married in that suit. And it's a humdinger. And so your answer when one leg's double the other, this is either the square root of 7.2, which is actually equal to 1.2 square root 5, if you want a simplest radical form, or 6 square root 5 over 5. And that'll work. Okay, notes are done. A lot quicker than Monday. And so for the homework tonight, let's take a look at some of these and show you what you're supposed to do. Okay, so make sure you got it all ready to go. And then let's give you some homework help. Okay, so for the assignment here, make sure you write notes 120, assignment 120. And when you're doing these minimal distance, assume that the bridge must be perpendicular to the two riverbanks. And so when we're doing this, normally the answer would just be, you know, what's the shortest distance between 2 points? Well, it'd be draw a straight line. Well, the thing is you don't draw that and then move it up and then just draw it over. It doesn't work that way. What you want to do is you take the distance of the river, right there, And that is how far, if you just have one river, you move in 1 point, not both. You just move one in. And then you connect the new point to there. Now, why does that give me the shortest distance? Once I move all this a little bit, like that. Because this piece from here to here, if you slide that up, which probably won't slide, because the whole thing, oh yeah, it did. It slides right up to there. See how that worked? That piece becomes here, and this piece, no, I just want the pink one, but it's connected. Well, the pink one goes to here. And then that is the shortest distance. Just like that. Okay, but you show your work. You show how you moved that in, and you show how that worked. Okay? Then just on these last ones, quick, if you're crossing two rivers, the width of this river, you move this one in. The width of this river, you move this one in. And that is how far you move that one in. That's how far you move that one in. And then you connect these 2 points from the end of that to the end of that. Well, the only part that you highlight, so your final path, need a drink, is that. And then you go perpendicular across, you switch that with that, then you switch that with that. And so then you'll go perpendicular across, and then you'll connect C to that point, and you'll connect that to that point. Okay? Then on the back, down here, just remember, x equals 3 and x equals 4. These are vertical lines. X equals 3. X equals 4. And then here, y equals x and y equals x plus 2. Well, that has a slope of 1. I should have made these blue for a river. And then this one starts at 2 and has a slope of 1. So if your river, that'd be a slope of -1 right there, okay? And then you draw the rest and figure out what it asks for. We won't do all your homework for you. We're just trying to help. And so the hardest one here, though, is this one. And it's actually in the book, at the way back of the book. And so you can actually find this in the book. But what you want to do is you take this point and you move it in perpendicular, that length. And you take this point and you move it in whatever this width was. And then you see if you can figure out what you're supposed to do. Okay, so 2 bridges are built and you want the shortest distance. So you're bringing this one in this way and you're bringing in this one this way. And see what you can get on that. And see if your answer makes sense. And see if you're confident in that. And then these last couple, find the shortest distance between the point and the line. And so you might be able to just get it from the picture. 0, 10. And then this goes through the origin. Remember, rise 1, run 3. Rise 1, run 3. This one starts at 5. Rise 2, run 1. This one starts at 2. Rise 2, run 3. And so the last one has a little star because it had a little star in the book. That means, ooh, really hard. But I think the problem above with the 2 forked rivers, that's the hardest one. And so email me your questions. Let me know. This is Mr. Nice and from his domicile. That was another word for a movie Hoosiers. Welcome to my domicile. That means house. And so we'll end with Coach Norman Dale telling his team in the movie Hoosiers, I love you guys. And so we miss you. And just let me know what you need. But some of you need to do the academic Super Bowl competition. We need your score. All of you can compete. It's not like I have to pick which 5 are going. And so you have your chance. And also do the interdisciplinary one, especially if you think you're so knowledgeable in science, social studies, English on the 1920s. And so look up those things. Make sure you remember what a one-to-one function is, mutually exclusive, and look it up and then take it. 40 minutes all at once for each academic Super Bowl one. So get the homework done And I helped you with that. So then do the academic Super Bowl ones before tomorrow night. Has to be done before 10 o'clock. And watch your time. You got to be done before 40 minutes is over, or they'll cut you off. And you can use a calculator. Okay? We'll see you guys. Looking forward to seeing your homework. And if you get your logic done, get it done. Okay. Bye-bye.